Using BIM to inform design. Building information modelling extends beyond 3D, enhancing the three primary spatial dimensions: width, height, and depth, or X, Y, and Z, with time as a fourth dimension, cost as a fifth, and project lifecycle management as the sixth dimension. BIM therefore covers more than just geometry. It also covers spatial relationships, light analysis, geographic information, and quantities and properties of building components, for example, manufacturer's details. As a practice, all technical staff have been using BIM pretty much full-time for the past 3 to 4 years. Before BIM, we used 3D programs to solve and sell the design, and a separate 2D program to draw up the schemes. The idea of using a single shared model to develop and detail a project was appealing, as it would help avoid information loss that often occurred between design phases and the design team. Our switch to BIM was, as a whole, relatively smooth. As a small practice, it was easier to implement a change to the working process. We were all used to computer programs, which helped the adoption of BIM. Although there were times when we wanted to throw the computers out the window because of irritating glitches, but nothing is ever perfect. We began using BIM on the detailed design and coordination of school projects, but are now using BIM for all new projects in the office, regardless of size, typology, or client. The aim is to use BIM from inception to completion to gain the full benefits throughout the project timeline. Fundamentally, BIM does change the way a project develops, as it puts emphasis on different stages of design. This is illustrated through the modifications to the traditional RIBA plan of works, which will potentially have a knock-on effect to the project fee structure. The use of increasingly collaborative modelling and design means relationships are changing between the design team. The UK construction industry is pushing towards Level 2 BIM as part of the target set by the UK government for 2016. Working at Level 2 simply means each discipline collaborates in a managed environment, using its own 3D model of the project, i.e. an architectural or structural or MEP model. There is no centrally held model of the project, and data exchanges use their own formats rather than an informed system. We are currently working at Level 2. The question of how BIM affects the way we approach design can be best explained by describing our BIM workflow on a variety of projects, as we believe design lies in all stages of the building process. We would like to address 3 key subjects: how we are interfacing with the model internally as architects, and the efficiencies and advantages we have gained as designers, how the design team interface with the model, and the benefits in terms of coordination, and how clients and stakeholders interface with the model, and the clarity and reassurance that creates. So, the architect. The moment the project is initiated, we begin to use BIM. When establishing initial feasibility and the brief, we use diagrammatic 3D modelling to establish massing possibilities. This is linked to schedules of areas and volumes, giving immediate output that can be quickly passed on to the client. At this stage, it is also possible to add cost ratios to the brief. We are currently working with one of our contractor clients to add this information to the model, so it is possible to make early realistic design decisions within the parameters of the budget. It should be noted that we still use sketching as a relevant part of the concept development. Once we have considered approach, we can then test the massing within the BIM environment to establish feasibility. A useful tool has been the ability to add 3D context. We are now able to get 3D site data created by photogrammetry for a few £100, accurate to 40 centimetres. So we are massing up proposal in its immediate and wider context, very useful on our commercial projects where clients are looking for rapid validation of proposals. As the design develops, we are attaching data and schedules to simple geometric volumes, which allows us to rapidly assemble a feasibility proposal and harvest the data that a client needs. It is also a valuable presentation tool for gaining pre-planning advice. For me, it's not a case of designing in a computer program or BIM. We use these tools to inform the decisions we make about design, about scale or orientation or context. For example, we are able to output 3D information for daylight and sunlight and thermal analysis without consultants having to build their own models, thus speeding up the workflow. Increasingly, we are doing this early analysis ourselves as the software becomes more available and easier to use. Here is the information we received after uploading our model over the internet to Green Building Studio. This rapid energy modelling means we can make early design decisions backed by principles and test concepts. Obviously, the project still needs to be sent to a specialist for full analysis, but hopefully the design will more accurately respond to its environmental context, reducing the need to make major design changes after analysis. Setting up the project in BIM from the outset means that as the design develops, we affect a model in a single environment throughout the process, simply refining and adding information so nothing is lost or wasted. In the past, we would redraw at each stage, wasting effort moving backwards and forwards from software to software, 3D to 2D. This clearly not only improves efficiency, but improves quality control as our team is always in the model. The model has become the centre of all activities, which as it is a vital prototype of the final product, can only be a good thing. As you see, the model is very intuitive to navigate and easily understood. You can see how this makes early problem avoidance second nature. There are architects in our office now who have only worked in this way. In the top left corner of the screen is the component library, and the bottom left navigates you to all outputs of the drawing we have chosen to take from the model. This is just another view into the model, which is a more conventional 2D representation. You can work in either view. The parametric ability of the software means a change anywhere is a change everywhere. By this, I mean amending the parameters of an object will subsequently amend the parameters for all the dependent objects. In the past, this has caused some setbacks, especially when all glazing disappears because someone has tried to change the size of a window. However, we have all learnt our lesson now. Work-sharing tools allow any number of designers to work in the same file at the same time, speeding up the design process, further improving quality control as a number of people are reviewing the same model from different perspectives. This has encouraged a culture of collaboration and shared goals at the micro as well as the macro level, and feels like a shift in working methods. The key point is that all our project information is kept in one file, which is a complete database of our contribution to BIM. From this one single model, any number of views into the database can be created: plan, section, elevation, detail, and schedule. As we progress to the level of detail at stage E, the elements in the model have performance criteria, but don't necessarily know what they are yet, what they're made from, their structure, or their finish. Once we are into production information, we then increase the level of detail to make it prescriptive, so the components know what they are. Tagging and annotation is intelligent. Further, it can be a piece of embedded information, such as specification, design life, thermal, fire, or acoustic performance. We deal with detailing in two ways. Firstly, 3D model detail. When creating a plan or section callout, the wall build-ups, window frames, and tolerances are shown. On this project, the contractor has procured the shuttering for the openings from our drawings, not the structural engineers, although this could be attributed to timing issues. If more detail is required, then we need to draw over the detail. This drawn detail gives the flexibility for adaptation, along with benefits of keeping the model size down, as it's not necessary to model everything. being able to include 3D descriptions of assemblies is proving valuable. The ability to quickly add 3D data to a drawing to explain the design is not only useful to the design team, but also the guys on site, as it reduces errors caused by misinterpretation. This slide describes the power of the process. All 4 schools are on tricky central London sites and are all completely unique. However, they are built using the same components: doors, windows, floor finishes, roof finishes, etc. So as we have gone from project to project, the data we have on the components has got richer and more detailed. Each project feeds into the next. This new college, a refurbishment project, was handed over in September 2012, and we were only appointed in December 2011. The ability to reinterpret or reuse existing data or components dramatically increased efficiency in our working methods, which allowed us to concentrate on getting to grips with the working requirements of the college, producing a viable scheme within difficult constraints of the existing building. The design team. This represents the biggest cultural change. We have been lucky to work with other design team members who use BIM to enable collaboration and coordination. Our design team meetings are now focused on the model, which is steadily becoming developed and enriched into a virtual prototype of the finished product. All 3D information from all sources is assembled into the model in advance of the DTM. This can include the models from members of the design team, fabricators, or suppliers. Client and design team collaborate in meetings around a table in front of the projector. The meetings have become more dynamic as everyone ends up standing next to the screen to explain ideas by pointing at areas, asking us to rotate the model, even trying to turn the model in their hands. They seem to feel more immersed in the project, increasing excitement as well as understanding. Generally, we use a construction model within Revit to check elements for problems, although there are specific tools to look for issues. This read-only information is very easy to use. Our 300 megabyte model comes down to 5 megabytes in Navisworks. There are guys on site with the models on their iPads. It helps that this software is free. As no 2 elements can occupy the same physical space, the software identifies any overlaps and creates a report that can become an action. The clashes can be hard or soft, as tolerances can be allowed for say insulation around ductwork or working space around machinery. These reports become the visual action list and agenda for the next meeting. The reports can be simple observations or as a result of clash detection. These are simply worked through and eliminated as necessary. Apart from the benefits of coordinating the models of the design team together to analyse design intent and construction, helping to drive out inaccuracies, there are other functions of BIM which we are exploring. We can view time in the model. The construction programme can be imported or linked, so it also becomes part of the model, allowing virtual representations, animations of alternative construction programs for comparison. Quantity and cost can become just another view of the data play. This makes material costing faster, easier, and potentially more accurate. In theory, cost estimators can create synchronized cost data linked to the model. However, on this project we have done a digital takeoff and a manual takeoff as a validation exercise. It threw up more problems than it resolved. At least it highlighted the need to have a very clear idea of what you want to take out of the model before you start. As long as the model is kept up to date, all information within the model file, this can be used as a part of the handover, either as a spreadsheet with all the data or as a 3D model with the embedded information. This would mean it would be possible to check the names of manufacturers, product catalogues, warranty information, in fact any information that may provide a better insight into managing the facility. stakeholder and clients. From the very early stages, we are able to communicate 3D dimensionally with the model. We can use a model to produce 3D sketches for early conversations with clients. The ability to look at 3D views reduces the risks created by misunderstandings and manages the client expectations. However, the model can be appended to the number of associated softwares, which allows the information to be used for different purposes. This makes it possible to validate the design efficiently by running simple animations around and through the building model using the working model. Obviously, the graphics aren't going to win any awards, but it gives a clear understanding of the proposals. We can use the model to communicate with people who can't easily read drawings in a way we haven't been able to before without physical or special one-off computer models. On a practical design level, it also helps to interrogate the model and identify and resolve issues before work starts on site. We can render the model to produce simple images for the client, which are adequate to make basic decisions. This accelerates the feedback loop by reducing physical prototypes and long rendering times, great for planning submissions, removing the need for specialist renders and animations except in special cases. It is also possible to link the model to high-quality rendering software, allowing verified views and presentation material to easily output as a byproduct rather than an end in itself. As it is using shared BIM, any changes can easily be represented by just rerunning the render. At first, it's fair to say I wasn't entirely open to the idea of using BIM. I felt comfortable using drafting programs and didn't feel the need to make a big change to use a new program. But since its implementation for use for us, the benefits far outweigh any of the disadvantages. Yes, it's not yet possible to draw overly complex designs. However, the modelling is far more intuitive and informed than a line drawing. It's easier to spot what will work and what won't work in a 3D world. For us to begin using BIM at the detailed design stages was a perfect introduction, as it was easy to see its advantages in reducing inaccuracies, and the efficiencies of producing schedules from the model was a revelation and meant the design team could spend more time resolving design issues rather than concentrating on the production of information. To push the use of BIM to the front end of the project was an obvious step, as it makes sense to work from one model instead of a multiple file types scattered throughout the filing system. The program itself is not going to design for you. It's only a tool that can be used to verify or support design, helping designers to base decisions on facts rather than speculation, hopefully helping to develop a strong concept at an early stage where it works within its context.